Hi everyone. In this video, we'll learn what is the most economical channel section and what are the conditions for the most economical channel section in case of some common channel sections like rectangle, trapezium, triangle, and a circular section. First, we'll understand what is most economic channel section. A channel is said to be an most economic or an most efficient whenever it can pass a maximum discharge. For a particular given area or the slope, whenever you get a maximum discharge, then you can say the channel is the most economical one. So this can be treated like this. You consider an continuity equation. From the continuity equation, the discharge is equal to what? Area multiplied by velocity. For a given area of the channel, this discharge will becomes maximum when this velocity is what? Maximum. Correct? This charge is maximum when the velocity is maximum. Further, this velocity is given by the Chezy equation that C into root of m into I. So in this C is constant. This Chezy C is what? Constant. For the given bed slope, that is I value, this velocity will becomes maximum only when this m will becomes maximum. What is m? M stands for what? Hydraulic mean depth. So velocity is maximum should have the value that is m should be maximum. Then what is hydraulic mean depth? M is given by cross-sectional area divided by wetted perimeter. This area is kept as an for an, you consider a given area, or the area will keep as a constant. For the constant area, in order to get a maximum hydraulic mean depth, we have to have the wetted perimeter should be what? Minimum. Wetted perimeter should be what? Minimum. So in order to get a maximum hydraulic mean depth, you have to have a minimum wetted perimeter. Then you can say the channel will be an economical. These two conditions will be used. That is, one is wetted perimeter should be what? Minimum. Wetted perimeter should be minimum, and the another condition is hydraulic mean depth is what? Maximum. Hydraulic mean depth is maximum. For if these two condition is satisfied, then you can say the channel is a what? Most economical channel. So okay, first we'll discuss the most economical rectangular channel. What are the conditions in order to get an most economical rectangular channel? First one we'll see, that is rectangular channel section. It is a rectangular channel. So what are the conditions in order to get an most economical rectangular channel? So I consider a rectangle channel. This will be the free surface of water. The depth I'll consider as a small d. Then b is what? Width of the channel. Okay, so now I'll write what is area. Area is equal to, I'll represent capital A, which is equal to length into what? Depth, that is b into d. From this, I can write b is equal to a into d power minus 1. P is equal to, width is equal to area into d power. Because why I use d power minus 1? Because it goes to the numerator as a denominator. So in order to get into numerator, it becomes d power minus 1. Similarly, wetted perimeter in case of an rectangular channel, it becomes, that is the channel boundary that is in touch with the water surface, that is b plus d plus d. That is b plus 2 times depth is the wetted perimeter. But what is b value? That is a d power minus 1 plus 2 into d. This is what the wetted perimeter. So in order to have a most economical channel section, this wetted perimeter should be what? Minimum. In order to get the minimum function, I differentiate this wetted perimeter with respect to the channel depth d. Okay, in order to have this p as a minimum function, if you differentiate the p with respect to the depth and equate it to 0, then you can say the value of p is minimum. Therefore, you get a most economical section. Now I differentiate this one. If I differentiate this p with respect to d, what happens? The a into d power minus 1 differentiation is minus 1 a into d power minus 2 plus differentiation of 2d is 2, which is equal to what? 0. So what I can write here, that is a divided by d square is equal to what? 2. Just I'll simplify, I'll write directly. What is area here? Area is b into d divided by d square is equal to 2. If you d with the square cancel, this b works out to be 2d. This is the first condition, that is the width of the channel section should be equal to 2 times the depth. Okay, next is I'll consider the hydraulic mean depth. M is equal to area divided by wetted perimeter, that is M is equal to area is b into d divided by wetted perimeter is b plus 2d. This one I have used here. Then further I can write M is equal to, what is b here? 2 into d. Into d it becomes 2d square divided by bd. B is what? 2d. From this I can write 2d plus 2d, it is 4d. If you simplify, square with d cancel, that m becomes d divided by 2. This is your second condition. What is second condition? The hydraulic mean depth should be equal to half of the depth. Then you can say it is a rectangular channel is most economical one. These are the two conditions for most economical rectangular channel section. Next we'll see trapezoidal channel section. Consider trapezoidal channel, that is, this is the width of the trapezoidal channel. So this I'll consider as free surface. Okay, the width I'll consider as b. This I'll consider as depth d. Okay, and which is having a slope. We take this as 1 in n. 1 in n. So by in the sketch I can write this trapezium is nothing but what? This rectangular portion and two triangular portion. What is this width? This width is nothing but b. Okay, so 1 in, that is for one vertical, the n is the horizontal. For the d vertical, what is the horizontal? This becomes n into d, and also this becomes n into, because these two are identical triangle, so I'll take. Now, so let me write what is this sloping side. Okay, so how to find this sloping side? Use Pythagoras theorem. This width you know, nd, this depth is what? D. So I'll write here, therefore side slope or the sloping side distance works out to be, side slope is equal to what? I'll apply Pythagoras theorem, that is square root of d square plus n square d square. You take d outside, the sloping side slope becomes d into root of 1 plus n square. This is the distance, that is this distance is nothing but d into root of 1 plus n square. Okay, this is the distance of the each side slope. So after this, again this principle remains same, that is area of trapezium. Area of trapezium is what? Area of this rectangle b into d plus 2 times the area of triangle portion, that is half into base into what? Height. Height is also d, therefore it becomes 2 into half into nd square. So if I simplify, area becomes bd plus n d square. So if I take d common, it becomes b plus what? nd. Therefore b is equal to a by d minus what? nd, but b I'll write it as a d power minus 1 minus of nd. Okay, so this is how you can write. Next, wetted perimeter. Wetted perimeter is what? The channel boundary in touch with water. This is one side, that is one sloping side plus width plus another sloping side. Therefore, it becomes P plus 2 sloping sides. Each sloping side is d plus d root 1 plus n square. Therefore, this is nothing but P. The wetted perimeter P is equal to what is B? That is A d power minus 1 minus nd plus 2d root of 1 plus n square is the wetted perimeter. In order to get the most economic trapezoidal section, this value of wetted perimeter should be minimum. Therefore, I'll differentiate this wetted perimeter with respect to the depth and equate it to 0 so that this p value becomes what? Minimum. If you differentiate this, okay, so let me write the differentiation. Differentiate this, I'll write here directly, that is a d power minus 1 differentiation is minus a d power minus 2, that is minus n, plus differentiation of this is 2 into root of 1 plus n square is equal to what? 0. Okay. Further, I can write 2 root of 1 plus n square is equal to a divided by d square plus n, that is 2 root of 1 plus n square is equal to, what is area here? Area is bd plus nd square, bd plus nd square divided by d square plus what? N. You take the LCM and simplify, you will get 2 root of 1 plus n square, which is equal to b plus 2nd divided by d. I take d to this side and 2 to this side, it becomes d root of 1 plus n square is equal to b plus 2nd divided by 2. This is your first condition. First condition for a most economical trapezoidal section, that is d root of 1 plus n square represents the sloping side. B plus 2nd, you observe here, this width is B, this is ND, this is ND, it becomes B plus 2nd is nothing but top width of what? The trapezium. Therefore, this is side slope of the economical trapezoidal section should be equal to half of what? Top width. Half of top width of the channel. This is your first condition of the most economical trapezoidal channel. Now to get the second condition, I'll use m is equal to what? A divided by P. Just I substitute m is equal to area is BD plus ND square. That divided by wetted perimeter is B plus 2D root of 1 plus n square. Okay. M is equal to, further I can write, this is BD plus ND square divided by B plus 2 into, what is D into root of 1 plus n square? The previous condition, it's nothing but half of the top width, that is B plus 2ND divided by 2. This 2 with 2 cancel. Further, I simplify, M is equal to, if you simplify and take this D outside here, if I take D outside, what is the remaining? B plus ND divided by, here B plus B is 2B plus 2 times ND. Therefore, if you take 2 outside, it becomes B plus ND only. This 2 cancel. M works out to be D divided by 2. This is your second conditions for the trapezoidal section, that is hydraulic mean depth should be equal to half of the depth of the tunnel. This is the same, the second case of the trapezium and the second conditions for the rectangle both are same here, the first condition. Next we'll see the one more condition for the trapezium section. So one more condition says that one is, this is what I take the angle as theta, the side slope making an angle of theta with respect to the horizontal or with respect to the base of the channel, the angle, if I take theta, what should be the theta value? Okay, in order to get this, the trapezium channel should be most economic. In order to get the side slope of the particular trapezoidal channel, so I need to take the wetted perimeter, okay, wetted perimeter P, and I should differentiate that wetted perimeter with respect to the slope n, with respect to the slope n, and equate it to 0. You'll get what is the value of n. Thereby, you can find what is the value of theta, because this is nothing but the triangle. If I take tan theta should be opposite by adjacent, because if this value is theta, also this angle is also what? Theta only. The inside angle is also what? Theta. So tan theta is equal to 1 by n. If you get the value of n, you can find the value of theta. So what is the condition I will use is differentiating the wetted perimeter, okay, with respect to the side slope, equate it to 0, you'll get what should be the value of n in order to have this trapezoidal section. If you differentiate the wetted perimeter, okay, that is b plus 2d root of 1 plus n square. So I'll write here so that you can understand in a better way. That is wetted perimeter p, that is differentiation of respect to dn, that is what is wetted perimeter, b plus 2d root of 1 plus n square. What is b value? B value I already written previous, you can check. A d power minus 1 minus nd plus 2 into d root of 1 plus n square. Equate this to 0, you'll get the value of n as 1 divided by root 3. Value of n as 1 by root 3. Further, I can write from the sketch tan theta is equal to opposite by adjacent. This one theta is opposite by adjacent. Therefore, tan theta is equal to n is 1 by root 3. If I take it becomes root 3. If you take inverse, theta works out to be 60 degree. So for the most economical trapezoidal section, the side slope angle should be equal to 60 degree with respect to the horizontal. If you maintain the angle 60 degree, the other two conditions, that is each side slope is equal to half of top width and the hydraulic mean depth should be equal to half of depth, is satisfied. This is all about the trapezoidal section. The third section, I'll take it as an triangular channel section. So I'll consider a triangular channel like this of an equal sides. So this is the free surface. This is the free surface, and I'll take a center line here. Each angle, subtended angle, I take it as theta. This angle is also theta. The total angle of the triangle should be what? 2 times the theta. And side slope, I'll take it as small a. Okay, so each side slope is having the same distance, that is same side slope is maintained, it is a, and this one is also a only. If this is theta, I need to find this distance. What is this half distance? If I take this triangle and apply what is sine theta is equal to opposite by what? Hypotenuse. Therefore, opposite side is equal to hypotenuse multiplied by sine theta, that is each value is what? A sine theta. This is also a sine theta. Then how to find this distance? Again, you take cos theta. Cos theta is equal to adjacent side. This I take it as the adjacent side divided by hypotenuse. So each adjacent side is equal to hypotenuse into what? Cos theta. That is a into what? Cos theta. Okay, so there are a number of methods in order to get the triangular channel section, but this method I found very useful. So this east side slope is a, in the total angle is 2 theta, or each subtended angle is theta. This distance is a sine theta. This is a sine theta. The depth will be what? A cos theta. Let me write the area of the channel. Area is equal to half into base into height, that is one triangle, plus this one is the 2 times half into base is a sine theta into height is a cos theta. Okay, so let me write a is equal to a into a, it is area square divided by 2, which is nothing but 2 sine theta cos theta. Therefore, area A is a square by 2 into what? 2 sine theta cos theta is nothing but sine 2 theta. I got the area. Okay. Next, wetted perimeter is the distance of the channel or the channel boundary which is in touch with water. Each side, that is A, this is A, it is 2A. Okay. But you observe in this channel, that is the theta is predominant in case of the triangular channel section. In order to have a most economical channel section, this theta plays a very important role. So what I'll do is, I can't use that section, that is P should be minimum. I'll use one more condition, that is hydraulic mean depth should be is maximum in order to get a maximum velocity. Therefore, what I'll take is, we know that hydraulic mean depth is equal to A by B, that is M is equal to area is A square by 2 into what, sine 2 theta divided by what, 2 times A is A with square cancel. M is equal to A divided by 4 into sine 2 theta. So I got M. Now you can say the value of M is dependent upon the theta. Okay, so therefore, in order to get a maximum velocity, this hydraulic mean depth should be maximum. For the most economical section, the Amor condition that what I'll use here is differentiating this hydraulic mean depth with respect to theta equated to 0. Okay, just differentiate this with respect to theta. A by 4, what is differentiation of sine 2 theta? It is 2 cos 2 theta. Therefore, it becomes A by 4 into 2 cos 2 theta is equal to 0. That is A by 2 into cos 2 theta, because this one will cancel with this like this, is equal to 0. As you observe, there are two terms. In these two terms, okay, this A by 2 cannot be equal to 0, because what is A? A is a side slope. This side slope, half of the side slope should not be equal to 0. Therefore, what is the another possible? That is cos 2 theta be equal to what? 0. Therefore, if you simplify, you get 2 theta is equal to cos inverse of 0 is nothing but 90 degree. Or you can write theta as 90 by 2, that is 45 degree. Each angle 45, or the total angle of the triangle should be equal to 90 degree. So when this is make a 90 degree, you can say the triangular channel section is what? The most economical one. Last one is the circular channel. In circular channel, there are two cases will come. One is to get a maximum velocity. What is the condition? The second case is for in order to get a maximum discharge. What is the condition? So let me take the, in order to get the maximum velocity, what should be the condition for a circular channel? So let me consider an circular channel. Okay. So the center, I'll take it as O, then which is running half full. This is the depth of the flow of water. The remaining depth from the center, I'll take it as y, small y. Okay. Now, if I join this, this will be what? The radius is r. I take the radius of the circular channel as r, and so the total angle, each angle I consider as theta. Therefore, the total angle becomes 2 theta is the angle of this total sector. So let me give this name as A, this as B. Okay, this horizontal distance, I take it as x on both sides. Okay, so from this triangle, in this triangle, you consider the triangle that one, each triangle, I consider this triangle separately. In this triangle, what happens? I need to find the value of x here. This is hypotenuse r. So if I apply sine theta is equal to x by r. Therefore, x is equal to what? R sine theta. X value is what? R sine theta. Similarly, in the same triangle, if I apply cos theta is equal to this y divided by r. Therefore, y is equal to what? R cos theta. These are all the values you need to find before. Okay, so then I'll write area of the channel here. So that is, what is the area of the channel? So I'll write it as, I need the area, only this shaded portion I need. So for that, what I'll do is I consider the total sector, that is sector OAB. In this total sector, if I subtract these two triangles, I'll get the shaded portion area. Therefore, area is equal to area of sector OAB minus area of triangle. Area of what? Triangle. Okay. So what is area of sector? That is half radius square into the total angle 2 theta minus area of each triangle is half into x into what? Y. What is x? R sine theta into r cos theta multiplied by 2, because it is an area of each triangle. There are two triangles, therefore it is multiplied by 2. If you simplify, you will get the area as r square theta minus sine 2 theta by 2. This is the area of the circular channel which is running half full. Okay. Now I'll write wetted perimeter P is equal to, what is the wetted perimeter? So wetted perimeter is nothing but this sector, that is sector boundary AB. The sector boundary is given by radius R multiplied by the total angle, that is P is equal to R into what? 2 theta. Next, so in order to get the value of theta, so because here the theta is the main thing which decides the channel condition, so you have to find the value of theta here. In order to find the value of theta, so let me tell you, I'll consider the Chezy equation, that is V is equal to C into what? Root of M into I. This V is equal to C into root of M into I. What is M stands for? That is M is nothing but what? A divided by P into I. So you observe this equation for a given bed slope, and the constant, that is C is a constant. Velocity is maximum only when this A by P is maximum, means hydraulic mean depth should be maximum, then the velocity is maximum. This condition already I told. Therefore, in order to get a maximum velocity condition, I'll differentiate this A by P, with respect to theta and equate it to 0, so that I get the value of theta. That theta is the conditions for value of that theta is condition for what? The maximum velocity. So this A by P means this works under what? The quotient rule. Okay, the differentiation will comes under the quotient rule. Therefore, I need to find out some values. I'll tell you. If there is a quotient rule, I'll take the area, that is what I'll write here, dA by d theta, which is equal to, you differentiate area with respect to theta, what you will get? R square into 1 minus cos 2 theta. Similarly, dP by d theta is equal to 2 times R, this one. Okay, so this is and this one. Next, you apply this quotient rule. What happens with the quotient rule? That is P into dA by d theta minus A into dP by d theta whole divided by P square equated to 0. Now you substitute that value. What is the wetted perimeter value? That is R into 2 theta into what is dA by d theta, that is R square into 1 minus cos 2 theta minus of what is A here, that is R square into theta minus sine 2 theta by 2 into 2R, that is dP by d theta whole divided by R 2 theta square equated to what? 0. If you simplify, you arrive at tan 2 theta is equal to 2 theta. This equation you will get by the trial and error procedure. You need to find the value of theta. You need to find the value of 2 theta. So from the trial and error, the value of 2 theta works out to be 257 degree 30 minutes. The value of the 2 theta is 257 degree 30 minutes, means the total angle, okay, the included angle should be equal to 257 degree 30 minutes in order to get a maximum velocity in case of circular channel. Now I'll substitute this value of 2 theta. I'll substitute the value of 2 theta in the area and as well as the wetted perimeter. You can get what will be the area. Okay, in terms of R, you will get here the wetted perimeter in terms of R. You will get, thereby you can find out what should be the depth of flow, that is D. So here from the sketch I can write the value of D. In that value of D, you substitute the 2 theta value as 257 degree 30 minutes. Also you can write theta works out to be 257 degree 30 minutes divided by 2. It is 128 degree what 45 minutes is your value of theta. So from the figure you can write depth D is equal to the total is radius R minus of Y, that is D is equal to R minus of Y is R cos theta. Therefore D is equal to R is 1 minus of cos theta. You substitute the value of theta and get the value of the depth of flow. Depth of flow is works out to be 0.81 times the diameter D. What I did is I replaced the radius by D by 2. Here replace R by D by 2 and substitute the value of theta here. You get the depth of flow of the channel should be 0.81 times the diameter of the channel in order to get a circular channel with maximum velocity. This you have to remember this theta value and as well as the D in order to get a maximum velocity. Next condition is for maximum discharge. See, everything remains same, that is area, wetted perimeter, dA by d theta, dP by d theta, everything remains same. So let me tell you, in order to get a maximum discharge, I'll take the discharge equation. Q is equal to area into velocity. We know that discharge is equal to area into velocity is what? C root of m into I. Further, I can write Q is equal to A into C into that is root of A by P into what? I. You take the area inside. Q is equal to C into root of A inside the root A square. Already A is there. It becomes A cube divided by P into I. In order to get a maximum discharge for a given side slope and the Chassis constant C, this A cube by P should be maximum. A cube by P, A cube divided by P should be maximum. So I get this maximum only when the differentiation of this A cube by P with respect to the theta and equated to what? 0. You will get the maximum discharge condition. So what this A cube by P, you apply an quotient rule only, the quotient rule only. So after that, you substitute the value of dA by d theta, dP by d theta, and further you simplify, you get the value of theta. So let me write here. So what you'll get, if I differentiate this one, I'll get P into differentiation of A cube is nothing but 3A square into dA by d theta minus A cube into dP by d theta whole divided by P square is equal to what? 0. Now you substitute what is dA by d theta, what is the dP by d theta, what is the value of A, what is the value of P in terms of theta, and simplify. You will arrive at 2 theta minus 3 theta cos 2 theta plus sine 2 theta by 2 is equal to what? 0. Okay. By the trial and error procedure, if you keep on substituting a value of theta and simplify, you will get the value of 2 theta as 308 degree. Therefore, theta value works out to be 154 degree. So the theta value of 154 degree, you get a most economical circular channel for maximum discharge. Another one for maximum velocity, this one is for maximum discharge. In the same type, if I take D is equal to that is R minus of Y, Y is R cos theta, that is R into 1 minus of cos theta. And if you take r as d by 2, the depth of flow should be equal to r. You replace r by d by 2. Theta value substituted as 154 degree. It works out to be 0.95 times the diameter. 0.95 times the diameter of the channel. So depth of flow is equal to 0.95 times the diameter of the channel. These are the conditions for the circular section in case of maximum discharge. Okay. Thank you.